for today's webinar topic, project management. Before we proceed to this webinar, I would love to talk a bit about Dr. Franz Busse. He's an esteemed aerospace engineer at Massachusetts Institute of Technology and Stanford alumnus, currently resides in Salt Lake City, Utah. As the founder of Grey Wolf Analysis Limited Liability Company, he brings a wealth of expertise to the field. In addition to his entrepreneurial pursuit, Dr. Busse serves as an adjunct professor at Brigham Young University, contributing to the educational and development of the future engineering professionals. His distinguished career includes impactful role at MIT, Lincoln Laboratory, Health System, and MIM Incorporated, showcasing his commitment to advancing technology and making meaningful contribution to the aerospace industry. We will now welcome Dr. Busse and hand over the rest of the time to him. Dr. Busse, you are welcome.
Okay, thank you very much. I am actually prepared some slides that I will be sharing. And I will say in advance that when I speak and teach, I love to be able to see the faces and expressions, and with a group this large, it is more difficult. And so I apologize if I'm not responding to puzzled looks on your faces. We'll do our best though. Okay, is that visible to everyone?
Yep.
Okay, all right. So as introduced, my background is all in engineering and managing. I've been involved with multiple startup companies, as well as a more established research and development center. What I thought I would share, so even though my background is in engineering, I have worked in leadership roles, and since this is being co-hosted by the Management Society, I thought I would focus a little bit on management, but I was going to give some thoughts from the perspective of managing jobs in the technology fields, okay? And so many of you that's certainly a large and broad area, and I think many of you may be interested in working in both in management as well as in technology, and I hope that these will be just a few useful insights. All right, so I'm going to give a little bit more introduction about myself, and then also some high-level thoughts about the topic, and then I wanted to touch on two things. One was really as a manager in a technology company, just some thoughts about managing technology projects and technology-related projects. And I thought I would also talk a little bit about teams and working in teams. That's just something which is really important in just about any job that you have in the modern world. And so I just thought I'd give a few observations and thoughts about teams, and then conclude. So who am I? That picture is not me. That is a famous sculpture, and I'll get to that in a moment. But just a little bit of background about my professional background. Again, my degrees were all in aerospace engineering. I've got my bachelor's degree from MIT, and then my master's and PhD from Stanford University in 2003. I then worked for 14 years at MIT Lincoln Laboratory. That is a research and development center. It does a lot of defense work, but also work for NASA and FAA and NOAA and other, but generally US federal government work is mostly what it does there. And it really is one of the premier science and technology institutions in the world. They're the ones who first launched a satellite, communication satellite, for example, and invented radar, or at least were based on the team who invented radar, and other achievements like that. After being at Lincoln, I then went to these two startup companies, Hala Systems. And a word about Hala Systems, that was a small startup which is more of a humanitarian technology. what we were working on was building an early warning system to warn Syrian civilians who were being bombed by the Russians and by Assad during the Syrian civil war. And we detected the incoming aircraft and would send alerts to the civilians, and they would have a chance to go and run and find shelter, potentially saved hundreds of lives. And that was a very meaningful job, and appreciated that. And then I worked at Mime Incorporated as another startup, which turned into, as a startups sometimes pivot a lot, and this one pivoted tremendously, ended up being much more of a technology, less mission focused, where Hollow was very focused on a mission of saving lives. Mime ended up being more focused on technology and development of more advanced technology. I've since left Mime, started Gray Wolf Analytics, which is just my own little consulting company. And then I also am teaching at BYU in the mechanical engineering department as an adjunct. That just means I teach part-time, and just recently started working at the Ballard Center as well. In my life, I'm married. I have 5 children. The oldest is 20, the youngest is 10. And the other really important thing is that my faith in Jesus Christ is really what defines me and motivates me. I've been involved in the Church of Jesus Christ of Latter-day Saints for my whole life and served in many callings there, which also flavors and shapes a lot of what I've done. My interest in my life now is really to bring my engineering background and apply it to humanitarian and social problems and challenges, and have social impact. And so that the picture of that statue is based on the scripture in Isaiah, which says, "They shall beat their swords into plowshares and their spears into pruning hooks. Nation shall not lift up sword against nation, neither shall they learn war anymore." And in my life, that is kind of what I'd like to do. I'd like to bring the expertise that I gathered building modern swords, right, radars and missile defense systems, and bring that into plowshares and pruning hooks, ways to help feed the hungry and care for those in need. So that's about me, and I hope that wasn't too long. All right, let's talk a little bit now about the topic, right? Managing technology projects. Working in technology fields, it has additional challenges, right? It's hard enough to work at any company, right? And to manage projects successfully. But in the technology fields, there's often additional issues. First of all, it's important that we remember that you are solving a problem. You're trying to make something better or fix something that's broken or improve life in some way. And part of that is, number one, you need to understand the job to be done, and that you're really focused on, you are trying to create something new that doesn't exist often. And so how do you know what to create? Is by understanding what needs to be done. What is the need? What is the problem there? And so working in the technology field, really have to be focused on that job to be done. It requires creativity and expertise. And when I say expertise, it's both knowledge and skill, right? There's both a mental expertise, and sometimes there's a very physical expertise in how do we build things and how do we actually make things so that they are durable. And my children are very, I think, get tired of hearing me complain, because all through life, I'm picking up a product, a phone, in my car, a thing in the kitchen, and always complaining about how badly designed it is and how it's a shame on those engineers. So you want to be expert in solving problems to do things right. It's not easy to do it right? There's always pressure to do it wrong. When you are managing technology projects, there are always someone who wants to pressure you to get the thing out into the field, get it done, and cut corners and do it poorly, so they can market their thing and make their money. And so you always have that pressure of, we want to do it right. We want to be careful and do a good quality job. And there's always pressure not to. The other thing with technology fields is you're dealing with unknowns. There is always a risk that it won't work, that you have a great idea, you want to solve a big problem, but sometimes it hasn't been solved because it can't be solved. And even if it can be, it usually is not solvable in the ways other people have tried. And even if it can be solved, frequently technology development projects take longer or are more expensive. When I was in my graduate school, my advisor would ask us, well, how long, when do you think you'll get this accomplished, right? And we would give him our goal, and he would always multiply it by pi, right? 3.1415926. Either the factor of pi, it's magic. That's how long it will actually take. So there you go. You often don't know where you're going to end up when you start. You know you want to solve a problem. You have an idea of this is what I think I want to build. And as you build it and as you test it and as you discover new things along the way, you often end up in a different place than where you started. And that also is a challenge in management. And you definitely will know the complications. And then on the side of that picture, right, here's the rule, all right? And this is absolutely true. When you are managing a project, a technology project, you're worried about performance, you're worried about your resources, how much money you have, how many people you have, and you're worried about schedule. You can pick two of those things, and then the third will be what it is. So you can give me a certain amount of money and a certain number of people, and you'll get a certain level of performance. Or you can tell me this much performance and this much money, and then it will take as long as it takes, or vice versa. So you can always bear that in mind, that you can't pick all three of those. All right. A word about management and leadership. Some people, often I meet people who want to use leadership for everything. We're all leaders. Everybody's a leader. We all want leadership skills. And that's, I think, a misuse of the English language. I will say that there is such a thing as managers and managing, and there's such a thing as leadership. And then there's such a thing as just being Christ-like and Christian. And sometimes people mix those. Management, think about a train on a track. Management is moving down the track as efficiently and effectively as possible, right? So the speed, the efficiency, the accuracy, the performance, doing it well. That's what management is all about. And that's really important. Leadership, I would claim, is actually more about getting on the right track. Before I start moving this train, am I going in the right direction? Am I going where I want to go? And that requires that direction, that vision, that inspiration, and doing the right thing. So leadership, do the right thing. Management, do the right thing well, right? And you'll want in your career, you'll play both of those roles, and you want to just think about that, right? It's like, this requires leadership. I really need to change what's going on here, or we're doing the right thing. We just need to do it better. This requires just being a better manager and being more on top of our processes. So just that thought. All right, with those thoughts, I thought I'd just jump in, and I apologize. Today's webinar is a little bit like a string of pearls here. I've just got some nuggets, and I hope you enjoy them. They might not be a continuous plot or theme throughout. So here we go. So when you're working on a project, right, we have a system design approach, and I really consider myself a system engineer and analyst and a systems person, right? And you will find sometimes you'll have a top-down approach, sometimes you'll have a bottom-up approach. But let me talk about it from a top-down approach, where you have a problem, something you are trying to solve. You want to provide better food and nutrition. You want to build a toy that kids will like. You'll have something that you are wanting to solve. And when you start on the left with the mission, and the mission is, what do you want to do? What are you trying to accomplish? You then take on the right side, you take, sorry, I'm using some old defense language there, but the environment and the threats, which really means, what can I not control? So for example, I want to make a delicious and nutritious food. What are the things I can't control? Where, all the environmental factors, all the other things, what is the marketplace? What are the people? What are my supply chains? What are all of these things? When I worked on defense things, it was very clear, right? It's like, I wanted to build a radar system, but it has to work in the rain, and it has to work in the snow, and it has to detect very small aircraft that are moving very fast. And those are things I can't control. So when we take what we're trying to do and what we can't control, the place we're doing it in, those combine to give us requirements. And you want to start any project with requirements, and requirements are things that you can quantify and things that you can test. And so you would say, I want to build this car that goes this fast and can carry this many people. And these are all things that I can then test and demonstrate that I succeeded at. When I've got those requirements, then I can look at the architecture and the technology or the processes, right? So sometimes to solve a problem, I can use existing technology. I can say, oh, I want to have this great big data, I don't know, web application. Well, I can use existing servers, I can use existing monitors, and the architecture is how many of them do I buy and where do I put them and who uses them how. Sometimes you'll be working on a problem where um, you can't do it. You need to invent a new technology. You need to say, wow, I'd love to, Steve Jobs had to invent his cell phone, right? To solve that. So different solutions will sometimes require just a different architecture, a different application of existing technologies, or a whole new technology. And even when you have that new technology, it has to be applied in the right architecture, right? You couldn't have had a cell phone without cell towers, right? And so on. So just a thought about as you think about the design process and technology. Okay, within that system, this is kind of what the development approach is when you in technology, right? You begin with that problem understanding. That's what we kind of taught was the top of that T on the last slide. What is the problem? What am I trying to accomplish? What are the conditions, the environment, and all of these things? Who is my user? Often you'll work in a company where there will be a product team, someone who actually understands the customers better, and they understand the problem, right? And they give that to the engineers who then turn those use cases and understanding the customer into hard things that you can build to and test, specifications that you can then test. And those are the requirements. That then goes over to the design process where the engineers, you brainstorm, you do literature research, you try to understand what's been done already. How can we do this? What are 10 different ideas? I narrow it down to 3 or 4 ideas. I analyze which of the alternatives, and I come up with a design, which I then send over to build, test, and integrate. And during that building process, I learn. And sometimes when I'm building and testing, I just discover that I made something wrong. The design said to do it this way and I built it that way. Whoops, that would be what I consider a bug. And you can test and find those. But there's a lot of times in that building process where you discover, hey, you know what? This design doesn't work, right? It's not doing what you want it to do. And then you have an improvement. You go back and change the design. And you continue that loop. Eventually, you get it to a point where it's ready to go and you can deploy it, or you send it out to the market, you start selling it, or you deliver it to your customers. And when it goes out, often you will discover things which I'm calling implementation feedback, where you discover, oh, we thought it would work, but once the customers actually have it, or once a user are using it, it doesn't work the way we thought it would. And so you have a feedback again back to the design. And then sometimes you realize, wow, I just built that whole thing and it was awesome, but that wasn't the problem. What the people actually need was I gave them food and they needed water, right? I built them a car or I built them a wagon and they needed a car, right? And sometimes you learn that and you go back to problem understanding. But the important point, the takeaway from this is just to understand that engineering and when you're doing technology development, there is a lot of iteration at every step of the way. And there's many of these loops. And you just have to understand as you're managing these projects that there will always be that build and test, learn a little bit, go back, maybe redesign, maybe just fix until you get the product that really solves the job to be done and makes happy customers. All right. Okay, we're not going to go through all of these things, but just these are some of the trade-offs that you will face or that a technology manager faces, right? And I already talked about that first one of done right versus done quick. Very often there's this pressure of I've got to get it out, so just give me whatever you can do, slap it together, get it out here so I can start selling it and try to make money. And when you do that, you often make mistakes and you often put out crummy products. That's related to long-term versus short-term, right? You can decide, hey, I want to design something which is just a short-term solution, a short-term fix, or no, I really want to build something which has additional features and really can last for the long term. You have a choice between building tools versus a total task time. And so I have that little graph on the left. And if any, I don't know how many of you on this call might feel like even though you're at a management phone call, maybe you're inside an engineer and have an engineering mindset. This is the test. Sometimes you'll be given a task, a monotonous task, go do something 1,000 times, right? And time goes by, you put in your effort, and a normal person, they just keep working. They just keep doing the same thing and keep producing. And they're that little blue line over time. They just keep producing things. You might be an engineer if you've been given a task like that and you start working on it and you get frustrated and you say, this is nonsense. There's got to be a better way to do this. I'm getting bored out of my mind, right? And then you stop and you build some sort of tool. You figure out how to automate it. And then once you've built your tool, then you take off and you start working again, and you're much more productive and much more efficient, right? So if you've ever found yourself in that situation where you can't stop but think about, there's got to be a better way to do this, you might be an engineer there, and think about that career field. Now, there is a danger here, right? Because sometimes if you have a low enough output that's only halfway up there, the normal person might win, right? If we only had to have 50 of them, well, just clunking away, the normal person doing that finishes before the engineer finishes building their tool. But if I have to do 10,000, then the engineer wins, right? So you just have to be aware of that. There's other trade-offs, system engineering versus agile, and I won't get into that too much, except to say there are management styles. Sometimes people are very much of, we do what I've been describing is more the old school of system engineering, where, hey, I understand my requirements and I have a waterfall of those, of how I decompose those into different components, and I've got a design, and I build to that design that will then integrate together and result in a beautiful end product. Agile means a lot of things to a lot of people, but often is characterized by very rapidly of, hey, let me just add this new feature, see what that gets me, and then add another feature and see what that gets me, and then add another feature. And it's a little more of honestly, a little more of a bottom-up approach of, hey, I can build a new capability. Can I sell that? Does that help? Sort of thing. And it's very, very popularized, especially in Silicon Valley, and computers and apps and things like that will do those. Whereas the aerospace guys, you don't necessarily want an airplane that was designed by an agile method. Oh, we know how to take off. We just didn't figure out how to land. Sorry. Anyway, so you'll face choices between very specific design for a very specific problem versus standardizing. So sometimes you'll have your team building a product, and you could build a custom cable, for example, that connects, one component to another, or you could take the trouble to use a standardized connection, like an HDMI cable, right? And I have to build my interfaces so that they can be standardized, but then I can use that same HDMI cable again and again in many different applications. And so you will sometimes face that choice. Do I standardize or use a standard and have to use all those interfaces, or do I build something just specific just for this problem? And sometimes there's times when one way will be quicker and easier than the other. You have to be aware of flexibility versus scope creep, right? Sometimes we want to build things that can do lots of things, but sometimes what happens is they call it scope creep, where you keep adding on more and more requirements, and you end up never delivering a product because you say, oh, but before we load it, we should also make it do this. We should also make it do that. We should also make it do this. And that can be the enemy of any project and any product that you're trying to get out, is that scope creep. You'll also always have the choice between open and source versus in-house. If you are in an engineering or technology company, you'll have this choice of, do I just hire the guys down the street or buy what they've got? Or do I build my own in-house exactly the way I want it? But then I have to build up my own internal engineering team and my own processes and capabilities, sort of thing. And that's always a trade-off as well, depending on the goals of the company, and things to think about. So those are just some of the different trade-offs that come up frequently in development projects. A word about hiring engineers. Some of you may want to be hired as an engineer. Some of you may want to be a manager who's hiring engineers. And these are just a couple of my thoughts, and very obvious. It might not be that different than any other field, but I've done it in technology fields. And the first thing you're really looking for is skill. And so if you want to be an engineer, first and foremost, it's nice if you're charming. It's nice if you have a big smile. It's nice if you have a pretty picture on your resume, but none of that matters. We want to know, can you do your job? Can you really build that? Can you write that code? Can you, build that circuit? Do you have the honest to goodness expertise, and can you demonstrate that? And we want skill that's both pragmatic and theoretical. I want to know that you know the equation of Kirchhoff's voltage law, but I also want to know that you know how to sit down and the limitations when you're actually trying to solder a circuit, right? And that's an example from just one field. But whatever your field is, there's often a pragmatic side of, hey, this is what industry does. These are the workarounds you can do, but also the theory of, hey, you have to have whatever laws of physics are involved there. Look for someone who's continually learning throughout your career. When you're 50, 60 years old, I hope you are still trying to learn the latest skills and understand the latest releases of software. And you need a good communication skills. You want someone who can write, someone who knows how to make a nice, clean, beautiful graph, someone who can make a clear block diagram, right? And who can convey ideas very cleanly and concisely and correctly to the other team members as well as to other stakeholders. You want someone who's responsible, right? Someone who works hard, someone who meets deadlines, someone who is accountable for their work. If they miss something, that they take ownership and say, yes, I missed that. And, what can I do to fix it, to make it right? And just someone who's mature, right? Someone who doesn't have tantrum or break down when things go wrong. You want honesty and integrity. Absolutely, right? So you want that, just number one, you would never, ever lie about what you have done or what your product can do or misrepresent your work in any way. And that's huge. And then passion, I'm going to talk about on the other slide. But these are things that you want to hire for someone. And if you want to be hired, these are the things that you want to have and you want to showcase in your interviews and in your hiring process and in your resumes. And for a lot of you, I'm not sure, but I think many of you have had difficult life experiences, where you've had to overcome real challenges to get as far as you have come, whether that's, poverty and not having food to eat or having trouble at home or an unsafe environment. And I would just recommend that you want to show when you are hiring that you have technical skills, but you also have those life skills that have made you stronger and made you more responsible and someone who can work hard and carry responsibility. And if you can tell that story, that will give you an advantage if you're trying to get hired for a remote job and you're getting hired versus, someone like me when I was 20, you would get the job because you have gone through a harder path and proven yourself. So that's just a thought that you can leverage to give you an advantage in the hiring process. A little bit about passion. I hope that whatever you do, whether you go into a technology field or whether you go into management or if you go into something else, whatever you're going into, be a craftsman, be the master of that craft, learn how to do it. I talked already about constantly improving. Take pride in your work and everything you do, whether you're just writing a quick memo to a colleague or you're giving a major presentation or you're delivering a product. Take pride in your work and say, if it's got my name on it, it's going to be good. I'm going to make sure there's no typos. There's no, I haven't misspelled anything. I've really reread everything and made sure it's all clear and concise. And I just take pride. Everything I communicate, everything I do is a reflection on me and my love of what I'm doing. And find a career, find a job which you can be passionate. And I know where you live, it might be limited options, but as we get more and more remote work options, and as you get more and more skill levels, that will open up more opportunities where you can find things that you do love and that you can be passionate about. And hopefully you can find joy and satisfaction just in your day-to-day work. And then it's not work anymore. Now, then it's fun. It's a good way to live life. Okay. All right, so those are my thoughts about technology. I just wanted to say a few words about Teams. I'm going to skip several of these slides so that we can have enough time for questions and answers. But I will just say that in engineering, so sorry, I lifted this slide from something else where I was talking to engineers, but in engineering, but in just about every job in the modern world, you will find yourself working in teams. And effective teamwork is a skill, all right? It's not something that just, hey, I just showed up and I'm a perfect team player. It's a skill that you actually have to work at and learn and improve. We've been talking about technology and design process. Teams are especially important in the design process, but any kind of creative work, when you are when you've been hired and you've been told to solve a problem, whether it's a technology problem or an implementation problem, you want to be in a team where you brainstorm ideas and say, well, what are some different options? How can we solve this problem in our project or that we're responsible for? Some of the key points about teams. One, diversity is essential. Having lots of different people with lots of different views is very important. Two, no one person is always right. And one day you might be a big boss someplace, you might be a CEO of a company someplace. You are still not always right. Okay. And you just, whoever you are, whatever position you attain, you're not always right. Three, this idea of diverge first. Be creative, think of lots of ideas, and then converge, right? Don't jump straight to the first idea someone says, okay, let's figure out how to work that. No, let's get lots of ideas and then pick from among them to decide and work on that one thing. Sometimes you do work together and you are all together in a room or all together on a Zoom call and talking and interacting. And then sometimes you work alone and then regroup. And there's advantages to both of those and different phases of a problem solving process. Sometimes you'll do one way and sometimes you'll do another. And so you just need to be comfortable with both styles of, hey, I can think on my feet while I'm with other people. I can also think alone, collect my thoughts, write it up, and then bring it back to the group and share ideas as a group. Some more ground rules. Everyone on the team should participate fully. And if you are a manager in charge of a group, it is especially your job to make sure that that's happening, to be looking around. We haven't heard from this person, right? Can I pull them in? Can I ask for their opinion so that I'm getting participation from everyone in the group? If you find you're the only one talking, even if you're the boss, stop and listen. Make sure, catch yourself and realize, wow, I've just been saying everything this meeting. Let me be quiet and give other people a chance or ask other people to chime in. On the other hand, be proactive. Don't wait to be asked. If you're the one who's been sitting on the sideline thinking, I'm the new guy here, I'm from this different country, nobody knows me, be proactive. It's okay to raise a hand and try to participate and move into the team. Communication between anybody, team members or otherwise, the 4 C's, you want to be clear, concise, convincing, and then correct, right? Make sure that you're right about what you're saying. But always try to phrase, especially if it's written, but also when you're speaking, right? Am I clear? Was I very concise? I didn't repeat myself 5 times. I didn't give a story that didn't matter, right? Was I concise? And then was I convincing? Was I able to give arguments or information that really helps them understand and believe what I'm saying? Now, teams will have conflict. It is good to have conflicting ideas. It's bad to have conflicting people, all right? So it's great if you're in a team and you have 3 or 4 different ideas that are all different because it gives you a chance to think through each one of those and find the advantages of each of those ideas and find the best ones out of that. But it's bad to be like, that was your idea and you are wrong, right? You can't have that on team, right? You never take it or make it personal. You focus on what is right, not who is right. And that's an important piece of working in a team, right? It's like, hey, we're all here to get ideas. And if you said 3 things that were dumb ideas, you're participating though. You're still helping and that's okay. You are still a useful and important participant. And so when you're in a team, it's always about what is right, not who is right, not, wow, I wish that guy would shut up because he keeps saying dumb things. Never in a team. That never belongs in a team, right? You always want to encourage and get that out. And yeah, I already made that point, right? When we're synthesizing conflict, right? When we're trying to understand why are these 2 ideas wrong, both different. Understanding that difference and the advantages of both ideas is what leads to a better design and understanding for everyone. And then you still have to be mature. I mentioned that on the hiring slide. you need sensitivity and diplomacy, even if you shouldn't have to, right? So part of being on a team is people are going to say things, and usually it's unintended. And even if it's intended, you want to be mature and not be offended. And you also need to be very careful in your words to not offend. So you could say, well, we're all here on this team and we've all decided we're not going to be offended, so I can say things however I want. That's not really true. We still have to be careful of, I still need to be sensitive, and when there's a bad idea, of how I say that's a bad idea, because even though we're all supposed to be agreed, it doesn't matter. People still tend to feel some ownership over their idea. It's their baby a little bit. And so we always still have to be sensitive and diplomatic when we shoot down bad ideas. You have to shoot them down, but just do it nicely and in a way that it's clear that I'm not, that the person who suggested it should not, take that personally. Sound fair? Okay. Oh boy, I have this great analogy that we're just gonna skip over. All right, you guys. But that was a great analogy about how in engineering you can prove that diversity helps. That when I have two different sensors looking at the same object, I can get greater accuracy, and you can prove that mathematically. And so just know that diversity is an essential quality with a team. I will leave these final thoughts though. Another word for team might be council. And if you're in the Church of Jesus Christ of Latter-day Saints, you will often hear talking about running the church with councils. And so everything that we talked about with teams is also true of councils. And so in your church callings, if you hold church callings, is something where you want to use that. And also family, right? So when you're with a spouse and with brothers and sisters and with children, these are also good practices and principles, whether you're in a family or a council setting. And then the final thought is a really good team is when every member should feel necessary and no one should feel sufficient. All right. And so no one member of the team should think I can do this all by myself. And if that's true, don't have a team, just go do it yourself. You're wasting everyone else's time. But generally, it's usually not true, in which case recognize, yeah, I'm contributing. I can bring something important, but I could not do this alone. And so that's how everyone on a good team should feel. Necessary, but not sufficient. Or, yes, right. All right. Ludwig van Beethoven, right? Don't only practice your art, but force your way into its secrets. Art deserves that. And I would say art, I read that more broadly as in whatever your craft is. For me, it was engineering, management, whatever your skill is, it deserves that. For it and knowledge can raise man to the divine. So as you really master your craft, it really does elevate you and brings you closer to the divine. And I've had that. I'm not an amazing composer and musician like Beethoven, who truly creates things that are beautiful that we can listen to. But even in my engineering, I have come up with designs or even presentations where I look back at it and think that was beautiful, and that was a great thing. And I feel a great satisfaction. I hope that that's something that all of you seek to have and can experience throughout your careers as well. And then this is Albert Schweitzer, a world-renowned Nobel Prize-winning humanitarian. At that point in life where your talent meets the needs of the world, that is where God wants you to be. And so I hope that each of you are successful in finding a place where you can, where your talents are able to be utilized and help the world be a better place, because that's where God wants you. And I share that with you as my closing thought and would welcome any questions at this point.
Awesome.
Okay.
Thank you so much. Yeah. Michael, go ahead.
Dr. Franz, thank you very much for taking us through this wonderful presentation. From our hearts, we say thank you very much. At this time, we would love to welcome questions, and we'll have you to respond to some of these wonderful questions that will be coming from our audience.
Mm-hmm.
your question, please.
Looks like Edwin has raised a hand.
Okay.
Yes, yes, Edwin is here. I happen not to be able to use my video now, but thank you once again. I want to ask a question about continuously learning. Your field has been in engineering. So, when someone is interested in engineering as well, but doesn't have the exposure beyond what environment gives. I know the internet is there, but would need collaborative exposure. For example, I wrote an email to a BYU Provo professor about I needed to learn MATLAB. So I said, I know a little bit of it, but I wasn't exposed project-wise. So how would you have any suggestion for someone to have a collaborative learning experience outside of the environment the person finds his or herself? That's one. Then two, you made mention of the agile process. Not that was really great. That we don't want to have an airplane that was made through agile. Through Skep, I've done project management, and that was really nice. So, is it fast and stone that it is waterfall through such maybe what is the criteria that it must be waterfall? What makes a project only being done through the waterfall method? So those are two. Thank you.
Great. Yes, very good. So the first one, yeah, that is tough. And it's cool. I think you said you were learning MATLAB, which is what I have used. It's been my workhorse throughout my entire career. I love MATLAB. Yeah, I agree. It is definitely preferable when you have people around you who you can learn from. And so if you do have that opportunity, you should take that. But in your case, sounds like you're not. You're kind of a little bit on your own if you're learning. Yeah, that's a really good question. I mean, and there you really do have to just be a little more scrappy about looking on the internet, looking for examples of code. If you're learning code, if it's, MATLAB or Python that you're trying to master. And unfortunately it is a lot. It's drier. It's a lot of reading. But you can learn that way, and MATLAB Help Center, for example, and I think every coding language and things like that, there are websites dedicated to Q&A, and just downloading other people's sample code and just looking at what did they do, what is their style that they've used, sort of thing, can be a great way to learn on your own. But I hear you. It is harder, to continually learn. And yeah, I don't know. I mean, it becomes quickly very specific, to a specific problem, where to go to read, where to find papers, just learn about new products. That's what my challenge is I don't keep up enough with, someone just released a whole new product that does this for you, sort of thing, and those sorts of things. But yeah, for a specific area, you need to find those hubs, in some cases GitHub, right? But you need to find those resource places where you can find examples of work that you can look at and learn from. That question about agile versus waterfall. So there is no hard, I mean, I gave you my opinion off the kind of informally. It is not hard and fast. And honestly, what I think is most successful is actually a hybrid of the two, where you start with kind of a waterfall structure, but within there you use an agile approach, for some of the smaller steps along the way. But I would say, if there is a general rule, the more serious things are, like the more serious consequence of failure. So things like vehicles and structures where, people would be killed if it failed, tend to lend themselves more to a waterfall approach, and things that are maybe a little less troubling if it failed, like my computer fails. Okay, I hit the power button and I restart it. I can deal with that. So if that was deployed through an agile approach, it's not as big of a consequence. My experience has been waterfall is a little bit better for more higher consequence projects or technology development. So there you go. Okay, there's a couple other questions on here.
Yeah. Yeah, Antia, go ahead and ask your question, then I'll ask.
Okay, thank you so much. Good evening, everybody, and thank you so much, Dr. Booth, for your presentation. Please, I have a little question here on this. I think that should be the second slide or two. You were talking about problems, requirements, and you made mention that we have a mission, requirements, down to environment stroke traits. Yes, I think, okay. Then under environment stroke traits, it says what we cannot control. And when I relate this to SMART goal, I know that in SMART, the T there is trait. Then I don't really understand, because it's what we can't control. So in our goal setting, in our businesses, in our career, how do you explain that to me, please?
So, let me apologize first of all if I get your question wrong. I'll try to give an inch-in answer. It might answer your question. It might be something else.
Okay, no problem.
When I am building something new, there are always things that I or my company cannot control. That it's just the way things are. And sometimes that's the laws of physics, right? It's like I can't change gravity. So my rocket has to be strong enough to lift against gravity because I can't change gravity. That's an example of the environment. I don't know if you have a more specific field, I could give an example. I don't know what you.
Okay, I have a specific field. Public health.
Okay.
In public health. Okay.
Great. So public health, I cannot control the characteristics of malaria. That is my threat. All right. And it behaves the way it behaves. And mosquitoes behave the way they behave. That is my threat. I can't control those. Now I can kill them and I can build a vaccine about them, but I can't control them, right? And so that's just an example of I have to understand what I'm fighting against, right, in public health. And that these are things I can't control. And so what I'm doing is I'm building a solution, but I want everyone to be healthy. I'm choosing, my mission is I want everyone to be healthy. The environment is there's malaria, there's mosquitoes, there's bad water, there's these things. And so my requirement is I want people to be healthy in the face of mosquitoes and malaria and bad water. So what are my solutions? Well, I can get netting, I can get vaccines, I can do all these other technologies I can bring up to solve that problem. But the nature of the disease, for example, is something that's beyond my control. I am responding to it and trying to counter it, but I can't change it itself. Does that help?
So much. Thank you.
Yeah. Thank you so much.
Yeah.
Dr. Buse. Okay. So my question is around the slide on development process. I actually have some series of questions here. I'll take them as much as I don't waste a lot of time. So when you were talking about the development process, I feel this is something anyone can relate to, not minding the field you are in. And while you were talking about this development process, like my mind went back to the work I have been involved with Scale Foundation in trying to solve the problem of unemployment. And unemployment is huge. It's huge here in Africa. It's a major problem. It's so huge that in a ward, for example, a ward where you have in the church where you have 50 members, you have like only 3 people who are able to work, who are able to fend for themselves in a ward. And that stops a lot of things, even progress in the world in terms of dividing the world and a lot of things, right? So it's a huge problem. And Scale Foundation has been involved in this for over the years. And so the past 1 year plus, getting to 2 years, I've been involved with Scale Foundation trying to solve this problem. And this is what has been happening. Like we have a problem, right? When we go through a design process, we're trying to find, solutions to all of these problems. And we build, we test, and what happens? It collapses. Go back again. So the structure we build, the ideas we have can't work anymore. For example, for past 2 years, we have been building a niche around medical billing and coding. And what happened just last year, AI came and swept away that ability to do the work, right? And coders in the US started using AI to do their job. So there wasn't any need for the 50, 100 people we were training over the years to do medical billing and coding. So we had to go back again to, find, and this is so I could relate to it. But my question is finances. Where does finance come in all of this process?
Yeah.
Because you can't tell me you don't need finances to do this.
That's right.
I want to understand that.
Yeah, no. So that's a great question, and you're completely right. They say a vision without funding, without finances, is just an illusion. Okay, and so yes, so this whole thing here does require money, right? And it does require, for your team to be paid, and for often to pay for tests and equipment and whatever else you need. And that's a whole different lecture. I'm sorry, your biggest question really is a whole nother discussion, but I will tell you that for the startups that I was with Hala Systems and Mime, and even to some degree at Lincoln, that was always the balance of following this cycle with all the iterations and doing it right, but doing it with the money that you have or are able to receive, right? And so for a problem that you're doing as this kind of a social impact problem, you need to have the foundation or the funders, right, which is often grants, things like that, need to understand that this is an iterative process and it does take time, and you need to be able to communicate that well, that there has to be a certain amount of patience involved in solving really hard problems. And then you have to have a compelling case. If you're for profit, suppose you said, hey, I just think there's a big market opportunity here that if I can solve this unemployment thing, I can make some money off of every job that I place. You need to explain that to the investor. And then, and that's what the whole VC and early stage investment community is all about, is a problem solver, the engineer or the person trying to solve the problem, understanding, hey, look, this is the road I have to go through. So I need to get enough money, enough seed funding to go through this process. And that's where it has to come from until you reach that point where you're either making money or you're having the impact that that founding or funding organization wants to have. And that really is a much longer discussion, which we probably can't get into right now, but it's your question is right on, Chidi. And it is very hard. That's the thing, right? I'm telling you, this is how you do it. It's this long iterative process, and it's longer than the guys you want to, because someone doesn't want to give you very much money. They want to get a big result without a lot of money. And that just doesn't work. You say, no, I have to follow this process. There's going to be iterative cycles here. It's going to fail, and we're going to have to do it again. And you have to be patient in investing or supporting that process. That's the story. Is we can't promise anyone, oh yeah, it'll be really quick. I can solve unemployment in Nigeria. Oh yeah, no problem. It's like, no, it's going to take a long time. It's going to be a long road. And my funders have to understand that to fund me through that. But you're right. That's the trade-off there. And I'm sorry, that's a very unsatisfying answer, isn't it?
No, I think, yeah, because I knew it's deep. Just wanted to get some insight. But another question I have here is something I have seen, in the job market, and which like I said, I'm very, very involved in, is that project management. For example, you see Robert have hiring project managers here and there, and though they are not hiring from outside the United States, but that gives me an idea that there's a huge opportunity for project management in the US for people to actually do remote work, right? So you've talked about understanding teams and being able to work in teams. Is there any other skills that we can start developing if this is a field that some of us here are interested in? Apart from you've talked about teams, working in teams. So any other skills?
Yeah. So again, I can speak to being a project manager in the technology field. Then that teamwork ability, that just gonna hold that up. This is what I was given as a younger leader, project management body of knowledge. And you can actually get a certificate in that. I don't know if it's worth the money or not, but just be familiar that there is this massive handbook of project managing skills. And they list all of these processes and things like that that you can know and should know. And when you are interviewing or applying for a job, that you can mention, yes, I'm familiar with the processes in the project management body of knowledge, right? So it's lengthy, but shorter than that, working in teams, good communication skills, understanding management tools, how to use a Gantt chart, how to set deadlines, and how to reduce risk, how to assess risk, and look at what are my highest risk and how do I attack those and reduce the risk on a project. And then just you need at least some background in the technology fields that you're managing. So I see sometimes people coming in with an MBA, a management degree, and not very much expertise in the actual technology. Their engineers that work for them hate them, and they're often not very successful. So trying to get as much technical background in the field that you are managing is always helps a lot. I don't know. There's a lot more things that we could add to that list, I suppose, but it's
Yeah, thank you so much, Doug. Okay, yeah. Houston, Bishop Houston, go ahead, please.
Okay, thank you so much, Franz. It was a wonderful presentation. I'm grateful that I'm here today. Please, just on project management. Recently, I was in a training where I'm trying to get a certification in facilities management. And one of the instructors mentioned that project management is not actually a profession. It is just a skill. And that no matter what industry or what profession you are doing, you just need to acquire those project management skills. And I just want to know, what's your thoughts on this?
Yeah, I would honestly agree with that. I got my degree in, my PhD is all engineering, and yet I ended up managing projects, right? And then fortunately, where I work, they gave me this crash course in these kinds of skills, right? Where they had a 3-day course that I could take, sort of thing. And I don't know if, David is cringing. He's like, oh, you need 2 years to learn those skills, not 3 days. But I think that there is wisdom in that advice, that all of you, especially if you want to be successful or are successful in your careers, will find yourself ending up in a management position where you are leading teams and leading multiple teams sometimes. And so it is a professional skill that I think everyone benefits from at some point in their career. And even if you never are a manager, knowing those skills helps you be a better employee, right? Because you understand what the manager is trying to do and you can cooperate with them, right? And you can be a much better employee when you know what a project is and how a team is supposed to work. So I think that's wise and good advice, that those are skills that everyone will need. And yes, you might get hired or given that position title, but you might not, and you'll still find those skills very useful. Sure.
Thank you.
Thank you. Let me go ahead and ask your question.
Yeah.
Okay, thank you so much. My first question is all about how can someone ensure that project requirements are accurately captured, especially when it comes to documenting, projects during the initial phase?
Yeah.
The second question goes because based on my experience recently, when it comes to managing IT projects, I want to know what's your what insight can you give someone who have challenges when it comes to validating and verify that project deliverables are met, especially based on specified requirements before finalizing the project?
Yeah, great questions. Very, very specific. So this is often what kills companies, is that breakdown in getting requirements correct. The last two companies that I've worked with really had a very clearly defined product team. And the product team are not necessarily engineers. These are the people who understand the users, and they'll put together the user stories and the user profiles. But then you absolutely have to have a step where that product team or product person meets with the engineers and translates those customer desires and needs and use cases and user stories into engineering requirements, which are, again, something that can be specified, is quantitative, and can be tested. Right. And so those two questions kind of end up coming together. When you receive requirements and before you start building, you want to look at each requirement and say, what is a test that I will write to or create to check off that requirement? And sometimes you'll have a requirement flow down, right, where you'll have a parent requirement, and then there's 4 children requirements that branch off of that, right? And for each one of those, you're saying, if all 4 of these child requirements are met, have I met the parent requirement? Will that always be true? Or am I missing something, right? And so that ability to think through how the problem decomposes from an overall requirement to lower children requirements, and just making sure. So one way to validate your requirements is to say, what test? How will I test that? And if I can't come up with a test, then the requirement is not written correctly. I need to frame that requirement in a way where I can test it. And then just making sure that you have the engineering team should be closely involved in that handoff from a product team. So someone who says, here's my user, it's Mary, she's a mother of 4 children, and she needs to do this job. And, she has this many hours, she uses a mobile device, all these kinds of details that you can user story. You need an engineer to look at that and ask, okay, so what kind of phone does she use? And how much bandwidth does she have? And what is she trying to do exactly on this phone? And does she need a map, or does she need content, and really go through those things. And then the engineer, I would have the engineers with the crafting of the actual specification requirements that are testable, because they put it in the right numbers and say, okay, I have to have 100,000 users simultaneously. Well, that will drive my Amazon web server, how much server space I need to buy, and whether I can use an S1 data bucket or some other approach, or I have to use Lambda, right? Those are some of the things. It's great to have a product team and a psychologist and someone who's just really friendly, understanding the user case, but you will then want to bring in the engineers to translate those use needs and job to be done into things that are testable and quantifiable. Does that help? I hope it helped.
Yes. Thank you so much. Thank you. I appreciate it.
Thank you so much, Dr. Buse.
Yeah.
So I think we'll wrap it up here. So we respect your time and.
Well, it's a pleasure, and I will say I've gotten invites from a number of you on LinkedIn, and I think I've accepted them. But if you want further questions answered or things like that, you can certainly contact me through LinkedIn, and I'm happy to mislead you some more. No, just kidding. Hopefully, give some useful advice.
Before we finish up, if you can, everyone turn on your camera just so we can see who's there. We know that the bandwidth can be difficult, and so it's totally okay that you didn't have your cameras on, but we just like to see, it's just fun to see you. So if you're able to, and you're in a spot where you can turn on your camera, turn it on so we can see who we've got here. And once again, thank you so much, Dr. Buse. That was a wonderful presentation. I'm sure all of us came away with inspiration. I know I did of certain things that I can apply in my field. So thank you so much. It's so good to see all of you. I love seeing your faces. Thank you for being here. And thank you, POE Management Society.
I love seeing you. Exactly. It's great. And good luck to all of you, if wherever you are in your careers or education. My best wishes, and I hope you all find awesome jobs and rock the world. Okay?
You will. Hey, remember how we end
Thank you.
Everybody reach up, give the hug. Come on. Give everybody a hug.
Thank you. Thank you.
Thank you so much. Thank you.
Feel the love.
Thank you, everyone. It's so good to see you.
Yeah. Thank you. Bye.
Thank you.
Thank you.
Thank you. Thank you. Zoom.
Great. Thank you.
Yes.